Alright, let's have a little look at the build of this. So, we turn it on, and it works, right? But that's not the main focus right now. I'll show you around. Right here is this screen. This is a 128 by 64 pixel screen, and it looks very, very nice. It is black and white, and it is OLED. This flickering that you see on camera is not in real life. It is just, because of the camera's refreshing. And yeah, it all works. There's 6 buttons, 1, 2, 3, 4, 1, 2. Your directional pad, and then your A and B. Right here is a little LDR light sensor that does work. It is not utilized. A lot of the stuff here is not utilized in this game, but it was utilized for some other projects, and it will be utilized a bit more in the future. Those just aren't shown off right now. Let's move to the back. Right here you have a switch. This switch just directly connects power, and it is a bit faulty. You'll see that if I hit it hard enough, the screen will just reset. You see how it does that banding thing? So it isn't a perfect thing. Right here is your battery charger. This is USB-C, so it is a little battery charger just like that. And it is aligned perfectly with the ground pad of the screen, if you see that. This right here is your Raspberry Pi Pico. It is technically not a Raspberry Pi Pico. It is specifically an RP2040 by Waveshare. This is not an official one. It is kind of like a rip-off version, but it is much cheaper. Right here you have a, what is it called? A potentiometer. This does work as well. Potentiometer is pretty cool. And this is a button hidden behind it that does not actually click in because I was not able to set that up. But if possible, it could click in. Right here is a battery. 150 milliamp hour battery, and then right here is a piezo buzzer. Piezo buzzer just makes sound, and again, this is not utilized in this project. Right, but that's a general overview, and it is all sitting on top of this little breadboard. Let's have a look at the actual software of this. So, when boot it up, it says 3, 2, and 1. So that flickering is just for you, and it is not actually here for me. That's about as good as I can get it. Let's delete it. And the switch on the back is faulty, so I will just give it a quick little boop boop. 3, 2, 1. First, let's go backwards. And right here, I can show you the collision, how there's collision on all walls. All walls except the outer ones have collision on both sides, as the outer ones were harder to test, and they possibly have collision on both sides. See how I'm colliding with each one? And I'll now sprint to the right. I move at 2 blocks a second, or 2 blocks instead of 1 block, sorry. And they are pixels. So let's go back down. As you can see, this comes back, but we did not get a lap. Let's go again and try it. Let's go the correct way this time, the way that you're facing. We need some of my sprint. Okay, it reset because of the switch, that's my bad. I'll not hold it so close to the wall, I guess. Let's go around. And you'll see that this actually all works out. And I do get a lap. So the way that this works is right about here is a little checkpoint. If I hit it from the right with a checkpoint value of 0, then I'll get a checkpoint value of 1, which means I've hit the checkpoint. And then if I hit it this way with checkpoint value of -1, then I do not get a checkpoint. It is set to 0. And if I go through this way with a 0 checkpoint, it'll set it as -1. And if I go through this way with a 1 checkpoint, it will set it as 0. So it basically checks in every single possible route what you can do, and it is really safe in that way where people can't cheat the laps. Something neat that I did was implement a stop running when you run out of sprints. So if you look right here, when I start going right, I will hold right and then I'll press B. I don't move because of that. And this means that you have to be careful with your sprints and you'll be slower if you waste them. Alright, so what makes this project, specialer than other projects? Right? The game that I showed really isn't that special. You just move around and it seems very, very boring. But you have to remember a few things. Other people that use Godot, like I did last checkpoint, or Unity, have a big advantage, right? They are things that they can just import. There's like, for example, flip sprite, which seems very simple, is not on this. I had to program everything from scratch. Any collision objects, just drawing the sprite in general. The only thing I get access to is to create the screen interaction, as this uses I2C and is not needed to be programmed by someone like me, as there are so many options available. Right? So I have much less ability to do stuff. I just had to interact with raw button inputs and raw screen inputs. I just say draw a pixel here, draw a pixel here, draw a pixel here, draw a pixel here. And because of screen code, I do get more access. I can draw a line and I can draw a sprite. And I had to make the sprite by hand, like that. This dinosaur sprite I did make on my own. So I have much less access to things that quickly help you make things. You just import images in Godot and Unity. You can import 3D models. I can't do that here. I have to hand draw each pixel, and it's much more difficult for me to make something. So this was meant to be an Arduino checkpoint, and I did not follow it properly. I used a different microcontroller that is not made by Arduino, but it shows very, very similar learning thing where I learned how to use potentiometer. You just gotta trust me that I've done this. Potentiometer, I've used this guy right here, which is a light sensor. And obviously I got button inputs, and I also got my screen to work. I also got a battery charger working, and a battery charger to power it all. Then I also got a switch. The switch being faulty is not my fault, it is the switch's fault. But it is able to power it. And I did a lot more actually connecting on this final build. I also have soldering skills, that's what it shows off here, with, what I've made. I've soldered it all together into one succinct piece, which is very cool, right? And even though my things are simpler, I have to go from scratch, like base scratch. I am putting the physical parts together. People get to use whole computers, and people get to, do all of that. Well, I had to deal with just, this guy, which is cool, but very, very low power, and I'm doing everything from scratch, right? Don't get any code to use. The next section is 24 minutes? Yeah, 24 minutes. So this is the coding section, explains everything. So this is a kind of, I don't believe that you actually coded this. You just stole code. I explained every single aspect of the code. So you're able to understand from that, and understand that I understand. You don't have to watch it all, but yeah, trust me, I did it. All right, let's get a little overview of the code. So this is my main.py, and as you can see, the Raspberry Pi Pico only has two things. There's a main.py and an SSD1306. SSD1306 is the code for the screen, and no, I did not make this. Here's a quick look at it, but I won't stick around here long, as it is quite simple. Two little lines of code, but it is quite complex and hard to understand and explain. I honestly don't really know what happens here. Said the wrong thing, sorry. So, have a look at the main.py here. I first do some imports. From the machine, I import pin, which allows me to use pins in general, I2C, which is how my screen connects, and PWM, which is pulse width modulation. Pulse width modulation means that you can basically turn on and off something really, really fast. This is how OLED screens dim, with them turning on and off, on and off, on and off, on and off, just keep on going. And this is also how speakers make different sounds, because it'll be on and pushing out the air, and then off, on and off. And the different frequency that it does it at will change it. On, off, on, off, on, off, on, off, on, off, on, off, right? You can do all those different things with PWM. Import time lets me use sleep commands and timer commands. Import SSD1306 is just importing this other file that is listed here. Import random, it allows me to use random, which is not used in this one per se, but it is an option, as a lot of this code is copied from previous projects, so that's why that random is still there. Then there's import math, which allows me to use math, which is just plus, minus, divide. And usually, in some actual programs like Godot, you do not have to do all this stuff. It is all, usually included. At least math is, random is, and you don't have to import them. But because this is the only file other than the file for the screen, I had to do all of this stuff. Then I had to import a frame buffer. Frame buffer lets me hold sprites, and then it will send them out later. It's a bit hard to explain. So right here, it activates an I2C bus, which means that, hey, I2C has SDA connected to pin 8 and SCL connected to pin 9. And then it initializes the display, which is an SSD 1306 display using I2C, which is a 128 by 64 display, which is over I2C. That is very repetitive I2C wise, but that's how it is. Next is this LDR, which is the light sensor, and it is on pin 29. Pin 29 is what is called an ADC pin, which is an analog to digital converter pin. So that one is, there. I do not use that one again. There's also a second sensor thing here, which is for the potentiometer. Then you have the 6 buttons, up, down, left, right, 1, 2. So you'll see that it has pin and then a number, that means which pin it is. And then pin in means, hey, this is an input pin, where it will basically ground it. So it will go power to ground, except it does it in a slightly different way because it has pin.pull up. That means that when it is open, it will be up. It will be what is called a 1, and then when it is down, it will be a 0. This is best for some reason. It helps you not have these issues in general with any shorting. Next is buzzer 1, and it defines it as a PWM thing, as I brought up earlier, for pin 7. So there's the buzzer 1 that uses PWM. Next is volume, and 16384 might seem very random, but if we open up some stuff and we do 16384 times 4, you'll see that it is this number, 65536. And then you search up what is significant about 65536. Is that the wrong number? 65536? No, it's the right number. And you'll see that it is 2 to the 16th power, which means it is the 16-bit limit, because each bit can have a 0 or a 1, and this signifies the sound. The max volume that it can get to is what? That number, 65536. And this is a quarter of the volume, which is 16384. Next is text centering. Text centering is just a variable that isn't actually used in this, but it is used in other projects. It is set to 0, and it is not used right now. Just switched is equal to 0, which is also used in another project, but whatever. Player X and player Y defines where the player spawns. So when I spawn in the player, it starts right before the finish line, or in that case, it would be the start line. It is both of them, a start and a finish line. And this is what is important for setting it. This will also get altered and will change where the sprite is displayed. This sprint previous player X and sprint previous player Y are used to check the sprint, because it checks if you have actually moved, because if you hold down B, your sprint doesn't actually change, which is kind of interesting. And this is an actual previous player X and previous player Y that allows me to check the previous player X and previous player Y and then adjust accordingly, and this is used for collision. Direction equals left, I'll show a bit later. This is sprint bar equals 50, which is how big the sprint bar is. For each sprint that you do, so the one that brings you 2 pixels forward, that uses up one of the 50, so it goes down to 49. Next is sprint logo X and sprint logo Y, which is just X and Y locations of the logo for the sprint. And then sprint bar X and sprint bar Y are the locations for the sprint bar X and Y. Same with finish X and finish Y. Laps counts the number of laps that you have, starting at 0 and incrementing to honestly whatever amount possible, unless it overloads. Checkpoint is equal to 0. This is what checks the checkpoint. Checkpoint equals 0 means there's no checkpoint. Checkpoint has not been met yet. Checkpoint X and checkpoint Y allow for you to change the checkpoint position. OG laps is equal to -1, allows me to quickly check the previous laps, but this one isn't actually properly used and was just used in debugging. Next is finish distance equals 16, which tells me how big I want to make the finish. I can scale the finish distance however big I want by just changing this variable. Next is finish line distance, which I can also adjust, and this is the line above and below the finish distance. This is specifically the one above, and then the one below scales 16 pixels bigger, or sorry, 32 pixels bigger, 16 on each side. And then this is a checkpoint distance, similar to the finish distance, checkpoint wall distance, and then this is just loaded, equals 1, and this does a 3, 2, 1 countdown, and then countdown 3, 2, 1. So this thing starts at 3 and will count down to 2 and 1. Next are the sprites. These are byte arrays. So we have dino right equals byte array. And if you look at it, this is actually the dinosaur sprite, 0 meaning black, 1 meaning white. And because I don't have any like, oh, you can just flip the character like you do in like you do in Godot, you have to kind of deal with this. And same with dino left, very similar. Then you have to basically initialize them as images into the frame buffer. So you have dino right fb equals frame buff dot frame buffer dino right comma 8, that means the width and the height, and then comma frame buff dot mono HLSB. Just sets it as a frame buff thing. This right here was my sprint logo, is my sprint logo. And because it is so few pixels, I decided to instead do it like this, instead of making a whole 8x8 sprite, as 8x8 sprites kind of take more space. It is much easier to just do this. And I also wanted to test different ways of doing things, because this dino, you'll see if I clip into a wall, will actually cover up the wall and causes a few issues there. This will just draw the pixel and will not draw over any other pixels and set them as 0. So let's quickly walk you through on how we draw pixels. You choose the X location and the Y location, and then 1 means white. So that's, a white pixel. And then this uses the same variables from up here with sprint logo X and sprint logo Y. See the same thing here, and this just maps it out off of the main point. So we don't really have to talk about that. Next is draw finish. Because finish is a dotted line, I need to figure out how I was going to do this. So it is another function and uses finish X and finish Y, and this uses OG finish Y. Because I change finish Y as I go through. So finish Y is 16 big. Finish distance is 16 big. So it draws a pixel, then increments it 2, because then it'll have 1 black pixel, and then the second one is white, and then 1 black pixel, second one is white. And it goes until the finish distance plus 1. So it draws an extra 1 that is unnecessary and will not be seen, but that should be clipping into a wall, so that's okay. And it increments it here with finish Y equals finish Y plus 2. Next is finish Y equals OG finish Y, which is just fixing up finish Y, as this would change finish Y's position, and I do not want that. Next is drawing all the walls around the finish, and these are very similar to the previous ones with the display.pixel, but now they're lines. So you say display.horizontal line, and then use this location, finish X minus 10, and then finish Y. So those are the two locations, and finish X minus 10 is set like this, so it can go, what is it? It goes 10 back. So 10 back is important because the finish line is not right on the edge. That's the idea of that. And then finish Y marks a finish Y position. And then finish line distance tells you how long to draw a horizontal line. And then 1, again, is just white. You do the same thing over and over and over again. And then you do 3 vertical lines that follow a very similar manner. Vertical, okay, X, 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 and then Y, 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 and then you draw lines, right? Then you have another display.h line, which is my little cut through line, as this is put in last. So while true means that this whole thing's gonna keep on running, and this is actually the main thing of my game. So I did not put these functions in it because I'm not gonna redefine the function over and over and over again. That is pointless. So first you fill the screen with 0, which is black, so display.fill 0. Draw the sprint logo, draw the finish line, draw the wall lines, and these are all functions, these 3 here, and then display a rectangle. So this rectangle here is for the stuff around the sprint bar. When your sprint bar goes empty, you can see how big it should be, and that is what this is drawing. And then it draws a filled rectangle, and this uses the 50 divided by 2 thing. So sprint bar was 50, as I brought up earlier, and it divides it by 2, and this fills up that rectangle. Next is just displaying text of a stringed version of the number of laps. So just display 0, and this is put as far to the right as I could. Next is previous player X equals previous player X is equal to player X, previous player Y equals player Y. So when you go through the whole thing, it will come back. So it goes down, 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 down. It will come back up, come back up, come back up. And then it will go through, and before you do anything, it will save what the last location was so that you can do any collision that is needed. So if the direction is right, then draw the dinosaur to the right. If the direction is left, then draw the dinosaur to the left. That is what it means. It draws two different sprites. They are actually different sprites. So this first checks for the sprint value, and if the right value is equal to 0, which again, we did a pull up, so that means that this is pressed, then player X equals player X plus 1. Okay, sorry. If button 2.value is equal to 1, this means that the value of button 2 is not pressed. So there's a little correction to that. Next, you set the direction. Direction is right, and then direction is left for this one. So the player X would go to -1, and the player X would go to +1 for left and right, respectively. Then you have the same with player Y. And there's no up and down values yet, as that wasn't really a crucial thing. Then you map these, which is the sprint previous player X and player X. So this just makes sure that everything is going right with the next section. So if button 2 value is equal to 0, which means that button 2 is pressed and sprint bar is greater than 0, meaning that you actually have some sprint charge, then right dot value is equal to 0. If right dot value is equal to 0, which means it's pressed, then you'll move 2. So they kind of are independent, because this one up here checks for if button 2 dot value is not pressed, and this one checks if it is pressed. So they will not overlap. Unless you have perfect timing, you can actually press it up until you get to these 2 points here, and then you let go. But electrically, that would be very, very difficult, and it's not like a millisecond thing. It is like into the nanoseconds, so that is not really a worry, right? And then it sets the right value and the left value, and it does the same thing. It just lets you move faster. And then it does a little check here where if you have actually moved, so if the things above actually took effect, then lower the sprint bar. If not, then don't lower it. So this right here is code just for testing purposes, and if the A button is pressed, then it ups checkpoint to 1. This is not really used, but I was having some issues and put that in, but it is not really, meant to be there. This just does screen collision, and honestly, this is also unnecessary now, as this game was a tech demo at the start. It was just to show what I could do in one computer science class. So we just put walls up, and these walls are never interacted with now, so they're quite useless. So next is wall collisions. So all the walls from here up are the dual-sided walls. That means that they can be interacted with on both sides. So these are really, really complex to explain, and you'll see that some if commands like this cut through wall goes on for a very long time. So let's first explain the very first one. If the player Y position is less than or equal to the finish Y position plus 1, so that basically means if your Y position is under where the finish Y position is, but you have some leeway, it's plus 1, then do it. But it also has to be player Y is greater than finish Y minus 8. So it puts you within a 9 pixel barrier of finish Y, with it being 1 pixel higher than finish Y and 8 pixels lower. But player X is what really matters here, where if player X is greater than or equal to finish X minus 10 minus 8, you make a why don't you combine that? I did this because this minus 8 here is kind of adjustable because I was very unsure about it, and you'll see that later on there's very similar things. Like right here has minus 8 plus 13. Right, so I just put that there. And player X is greater than or equal to finish X minus 10 plus finish line distance, then change the player Y to the previous player Y. So let's open some MS Paint. Load it on the other side instead. And let's draw out the idea of what's happening, right? So you have a line. Can I do it? Okay, give me a second. Okay, there we go. Straight line, right there. And let's say I am a character. If I am in this location, I am in between this line right here, and I'm in between this line right here. But I am not between, okay, this was unrealistic because the walls are actually 2-dimensional and not 1-dimensional. So here's the wall, right? It is about that. Let me just fix that with a few proper lines. that, like that. And we can just draw another line like that. So it is between those two confines, but those two confines being this guy right here and this guy right here, but it is not in between these two confines. So that's what matters there, right? Let's draw a second one where it is within the wall. So it is within all four confines, and because of this, it will send you backwards. So the way it works is first you start in this position. Once you move up by one, you'll be within the wall, right? And because it saved your previous player location, once you're within the wall, it will say, hey, there's something wrong, let's send you back. So it'll send you back up like this to this original position right here. So that's the idea of that, right? That's how all the walls are done. So all the walls follow a very, very similar thing, and I don't really want to explain them all. They are all based off of relation, so that I'm able to just quickly go up here with the variables and tweak anything I want. Do I want to change the finish line distance to be 50? That's totally fine. I can just do that. And that's the general idea there. And it made it much simpler for me to make edits, not much simpler for me to actually change what the hitboxes are. But the cool thing is I don't have to do that anymore. So this is the dual wall finish thing. So the ones above were dual wall finish, but this one is not. And the only difference here is you'll see that this one is actually only 1 pixel big, which should cause issues. I'm surprised that didn't cause me any issues. Usually 1 pixel big means that you can sprint down it, but I'm sure I've tested that one. You cannot sprint down it. So, ta-da! I will make a quick change to this sometime, but this basically checks the same thing, but in a much smaller size, as I don't really want to test it and didn't really want to cause any issues. So the next one is the finish line and the checkpoint line. These are also collisions, but not ones that actually change your location. So it checks in the same way that the other ones are for collision. And then this right here resets your sprint bar to 50. Just resets it right away. But if your checkpoint is equal to 1, which is below, it'll explain it below, then your checkpoint is equal to, okay, if it is 1, then increment your laps by 1. So this plus equals 1 just means laps equals laps plus 1, and then it drops your checkpoint back to 0. Next is the checkpoint line. This one is a bit more complex to talk about. Again, it checks collision just like it always does in other ways and other locations. And it first does a check. Because previous player X and previous player player X show me which direction you're going. Previous player X being smaller than player X means that you went from the left to the right. I can also check this with my variable, which is the position that you're facing, called direction. Direction equals left. But this was a bit more simple to do, and it is very, very guaranteed. And honestly, there's not much reason to fix it. So if you're going from left to right, which is the way I expect you to do it, and checkpoint is equal to 0, then checkpoint is equal to 1. Just change checkpoint. If previous player X is greater than player X, which means you're going from right to left, and checkpoint is equal to -1, change it to 0. Right? If previous player X is greater than player X, which is the same thing as above, so technically these ifs could, this and here could be nested under as another if option, but I wanted to make sure about this that it worked perfectly. So if previous player X is greater than player X, if the checkpoint is 0, then change the checkpoint to -1, and if the checkpoint is 1, change it to 0. So -1 basically means you're screwed. You are on the other side. I'm not going to stop you from going to the other side, but when you go back, you'll be set to 0. So you won't actually get what you should be getting. This thing right here was just as a sanity check to tell me what happened. And then this right here also just tells me what the checkpoint is. Display.show is just load the display. And I put this here before the 3, 2, 1 countdown, because the 3, 2, 1 countdown, I want to show up on top of the background, which I did. So it does a just loaded check, which is what I did up at the top here, with just loaded equals 1. So I said if just loaded is not equal to 0, because I had a different plan when making it, where just loaded would be incremented and would be the countdown instead, but I didn't fix that. So I can technically change this to if just loaded was 1, but whatever. If countdown is greater than 0, because 0 means that you're at the go value, then display text, the string of the version countdown. So that's the one that started at 3, and it displays it at the location 64, 32, and then in the color 1, and then it shows, and it sleeps for a second, and then it shows it again. This else if command is for if countdown is equal to 1, where it only shows for 0.85 seconds, so that can show go for longer. So countdown equals countdown minus 1, so this brings it down. So from 3 to 2 to 1, and then to 0. And then if countdown's on 0, then display go, and this 64 by 32 is actually misaligned. So I will just give this a little fix and change this to 56, as this is how it should be. Now I'll save, as I can do that. So this will also just display sleep per 0.15 seconds, which is basically if you add it with this sleep here, the time.sleep 0.85 seconds, then that ends up to be 1 second exactly. And then increments countdown down by 1, which is honestly pretty useless because I can just put this just loaded thing to 0. So I can do this if I wanted. But I wanted to be very sure, as maybe I could put stuff afterwards. So it is just to make my code a bit more portable and usable. So that's the idea there. So that is my whole code all explained. Hopefully, you learned something from it. Sorry for the 23-minute video.